would be our common denominator? Okay, now remember that x minus 2 and x minus 3 are very different things. They're very different numbers. We can't just add a number to x or change just the constant, right? It's grouped together. It is an actual term or a factor. So our common denominator is going to be the product of the two. You can't just add a number to each side. We can't just add something, right, onto the numerator or denominator. We can multiply top and bottom by the same thing. We can't just add something on. So our common denominator is going to be x minus 2 times x minus 3. So what's the first fraction missing? X minus 3. So we need to multiply the numerator and denominator by x minus 3. Okay. Now, should I put x minus 3 and x minus 2, the original, each in brackets? At this point, right now, where it's multiplication, I don't have to. But if I'm going to expand, are we going to use just like distributive law, or is it going to be FOIL? FOIL, right. So it is safe to put them each in brackets so that when we expand the numerator, we're going to FOIL. Do we expand the denominator? No, we leave it factored. We always leave it factored. Plus, okay, the second fraction was missing which factor? X minus 2. Okay, and this is, 2 over times 2 over x minus 3. Okay, so let's simplify that. Gives me, now if we want, we can go straight to writing this all over the common denominator of x minus 3 times x minus 2. We don't have to write them each under that common denominator, especially with this addition. And if you want, you could write this extra step of x minus 3 times x minus 3, or we can go straight to FOILing. What would you like to do? Just write it out? You don't? Okay, well, let's write it out. X minus 3 times x minus 3 plus, could I rearrange x minus 2 times 2? Sure, I usually put the constant first. Okay, so you can go straight to writing it all over one denominator. And now expand and simplify your numerator. So expanding x minus 3 times x minus 3, what would that equal? So quiet today. X squared minus a 3x and minus a 3x. So what would the middle term become? Minus 6x. Good. So you're going to get negative 3 and a negative 3. Right? Right here and right here. And then the last, negative 3 times negative 3 gives you plus 9. Good. Plus, bringing in the 2, the distributive property. 2 times x, 2x, and 2 times negative 2, minus 4. A lot of writing. And not as much fun as when we got to cancel all those terms. Okay? Okay, so collecting like terms, what's my numerator going to become? X squared plus or minus? Minus what? 4x's plus 5. We always check to see if we can factor the numerator, just in case something factors. It doesn't always, usually it or cancels. Usually it won't cancel, but we double check. Is that factorable? No, the sign's incorrect, right? It doesn't factor because this is a plus 5, so the only way to do plus 5 and add to a negative is negative 5 and negative 1. That would add to negative 6. So it's not factorable. So we're finished, except for one thing. NPVs. X can't be what? Plus 3 and plus 2. There's our answer. All right. Next question, what's the common denominator going to be? Yeah? Thank you. Thank you so much. You're live. Okay. Common denominator. Anybody? Anybody? I feel like I'm on Ferris Bueller's Day Off. Okay, so what's common? They each have an x. Okay, would I need to include it twice? No. And then each factor. So we have x plus 5 and x minus 1. Just a product of all the factors represented. If it shows up at both, we only need it once in our common denominator. So the first number, in the first rational expression, what are we missing? X minus 1. So we're going to multiply top and bottom by x minus 1. You can put it on the left side or the right side, doesn't matter. Key is we're multiplying top and bottom by x minus 1. Now I like to put my binomials in brackets so that it reminds me that I'm going to need to FOIL when I expand the numerators. What's missing from the second one of 2x minus 3? X plus 5. Good. Heard some whispers. Okay. So if you want, we can, just to save your wrist from all the writing, we can go straight to writing this all over one denominator. So our denominator is going to be that common denominator. Do you want to start expanding? Sure. Let's do that. Okay, expanding x minus 1 times x minus 1. We are going to do what? FOIL. Okay. So now we expand and simplify the numerators. Denominators we always leave. The denominator, leave factored. Okay, so x squared, what's the middle term going to be? It's a perfect square, right? So negative 2x. We can multiply those first, the x times the negative 1 and double it. And the last term will be plus 1. Good. Plus 2x times x, 2x squared. The middle term is going to be 2x times 5, which is what? 10x minus 3x, because negative 3 times x. What's 10x minus 3x? 7x. And then negative 3 times 5, minus 15. Collect like terms. 3x squared. How many x's? 5 x's. How many constants? Minus 14. The last step is we have to check to see if that's factorable, because if it is, something might reduce out on the numerator and denominator. So we have to check. Is that factorable? So 3x just on the side here. Okay, so 3 and 1. We could try 7 and 2, I guess. Will that work? No. Even if I make my signs different, I switch it. 7 and 2. That gives me 6 and 7. That won't work. What else is there? 14 and 1. So we try 14 and 1. So 3 and 14. Will that work? No. If I switch the 1 and 4, will that work? That's going to be huge. Definitely not. So is it factorable? No. So we're done except for one thing. And PB's x can't be 0, negative 5, and negative 1. Nope, nope, positive 1. Thank you. Ooh, good thing you're paying attention. There's our answer. Okay. How do you think we're going to go about number 3 to find the common denominator? factor. Makes life a lot easier. Because if I had to multiply y squared plus 5y plus 6 times y squared minus y minus 12, that's going to be huge, right? So if we factor, we can see if they have common factors. So let's factor each of those to start. Let's use 4 over. What does that factor to? Y, and our two numbers, our product is 6, our sum is 5. 6 and 1 or 3 and 2? 3 and 2, good. Minus 7 over. Okay, we want to add to negative 1, multiply to negative 12. Probably 4 and 3. Which one's positive? 3. Positive 3, negative 4. Good. So now it's easy to see what would my common denominator be. They each have what? They each have a y plus 3, so that's nice. The first one has a y plus 2 that the second doesn't. The second has a y minus 4. So it'd be the product of those three. So what are we multiplying the top and bottom of the first fraction by? Y minus 4. Y minus 4. So we're going 4 over y plus 3, y plus 2. And why can we multiply top and bottom by y plus 4? Oh, minus. Because what's that equivalent to? Y minus 4 over y minus 4. It's just 1. It's equivalent to multiplying by 1. Good. What's the second fraction missing? Y plus 2. I don't know if you noticed, there's a lot of writing in this unit. Okay, so let's simplify that. Could we go straight to writing that all over one denominator? Sure. Now with subtraction is where you need to be very careful. So it's nice to write this just let's write, before we expand, let's just write this all on one numerator. So we have y times y minus 4, and then plus 7 or minus 7? Minus 7 times y plus 2. Bring in that negative with the 7. Okay? And by doing that, we're a little bit more safer when we expand. That negative is where we can make mistakes. Okay, so use distributive law in the numerator. We have 4y minus 16. And then what? Minus 7y minus 14. Good. We're just bringing in the negative 7. Okay, when we collect like terms, what does that give me? How many y's? Negative 3. Take away 30. Okay. We always like to factor the numerator if possible to check to see if anything is going to cancel. So what can you factor out of the numerator? A negative 3. And that will leave me with what inside the brackets? Oh, I'll go upstairs. Y plus 10. We divide both by negative 3. Does anything cancel? No, but at least we checked, because sometimes it does. It doesn't always happen. It usually doesn't, but sometimes it does. Sometimes there'll be a factor on the numerator. Denominator can reduce out. And finally, we can get to our NPVs. Oh, good thing there's only 2 pages today, hey? Oh, no, there's 3. I lied. Darn it. Sorry. Hopes up, and then crushed. Y can't be what values? -3, -2, and 4. Okay, I feel like you should try number 4. Well, at least start the first step. Okay? So start the first step. Where are you going to start the first step? Factor. Okay? Plus 2 minus 1, and you can factor 3 out of the denominator. It gives you x plus 2. Yes, so we can't cross reduce, but we can reduce within the same fraction. So those can cancel out. Is that going to make this question a lot easier? Yes, I'd like you to solve the rest from here. Okay? So now we're dealing with, instead, x plus 3 divided by x minus 2. Take away x minus 1 over 3. Quick question though, when we do NPVs, am I going to have to include the ones that canceled? Yes, when we state at the end. Go back to the beginning to this factored form and state your NPVs from there. Okay, solve the rest. You can do it. Yes, you can. So when you FOIL the second one, you might want to leave that all in brackets because there's subtraction, right? Can factor it. My hint is factor out the negative out of the numerator and then factor your final expression if you're already there. So factor the negative out of the numerator and then factor it. I mean, you could factor it from there, but usually we like our x squared to be positive. So be very careful of that subtraction, right? I FOILed first, but I left it in brackets because I want to subtract that whole polynomial, just looking at the top up here, right? So I FOILed out this x minus 1 times x minus 2, but that expansion we left in brackets because we want to subtract that whole thing. So bringing in the negative, we get negative x squared plus 3x minus 2. And collecting like terms, negative x squared plus 6x plus 7. We want to factor this, but before we do, it's not common to have, we don't like negative x squared. So factoring out the negative out of the whole thing, then it makes it a lot prettier to factor. X squared minus 6x minus 7. Product of negative 7, sum of negative 6, negative 7 and 1. Does anything cancel? No. But we checked, and that's what matters. What are the non-permissible values? Where do we have to look? Before reduction. NPVs before reduction. So in the very beginning of the question, when we factored, what were those NPVs? Right, where we're looking at the denominators here. What were the NPVs? Plus or minus 2 and negative 4. Plus or minus 2 and negative 4. And that should be your final answer. Okay. So again, most addition subtraction questions don't end up simplifying, but occasionally they do. So we always check by factoring the numerator and if possible. Okay. All right, one more page. I'll be really quick. And there's complex fractions. So turn over. Okay. You've already seen these. Sorry. There's method 1, which is do the numerator and denominator separately and then divide them, which takes a lot of work. So the trick is method 2, which is multiply the common denominator, and it gets rid of the fractions. So in this question here, I should say red, not ride of the fractions. Sorry, typing too fast. What would be the common denominator? Well, what's on the denominator? Specifically in each, like looking at, we're talking about denominators, we're talking about those two. So what would it be? 6. So I'm going to do method 2 because it's a lot easier. So it's 6. So we're going to multiply the numerator and the denominator by 6. So I'm going to multiply the numerator by 6 and the denominator by 6. This will eliminate our fractions. Is that legal? 6 over 6 is still 1. So yeah. Okay, so what's 6 times a half? 3. Plus, what's 6 times x? 6x. Divided by 3rd times 6. 2 minus 6x. Okay, so a couple of things here. We like to leave it in factored form. Can we factor the numerator and denominator? Yeah, what can you factor the numerator? 3, which is 1 plus 2x. What can you factor out of the denominator? 2, which is 1 minus 3x. Okay? It's a lot easier to see our non-permissible values when it's in factored form. What can x equal? Excuse me? This is a little backwards, right? So if I have 1 minus 3x can't be 0. So add 3x to the other side. Divide by 3. X can't be 1/3. Okay, pretty simple, hey? Once you get rid of that fraction, it's not that hard. Okay, what's the common denominator of this one? 3x. So, we're going to multiply the numerator by 3x and the denominator by 3x. Okay, so distributive property. What is 1 over x times 3x? 1 over x times 3x is 3. The x's cancel out. 1's on the numerator, 1's on the denominator. Plus 3 times 3x, 9x over, okay, 2 over 3x times 3x. 2 plus 6x. Okay, let's factor. What can you factor out of the numerator? 3. Get 1 plus 3x. What can you factor out of the denominator? 2. We also get 1 plus 3x. Hey, does something cancel? Finally. So our final answer is 3 over 2, comma, x can't be equal to what? Negative 1 over 3. All right, that's it for today. How was that? Does your head hurt? No? Yeah, I already wrote the homework on the board. It's in your textbook, so grab your textbooks. Yes, every day bring your textbook. Page 336 to 340. Number 6A. It's A through F because E and F are AP questions. 7 through 9. And then 10 is an AP question, AB. And 15. And I'm supposed to say good afternoon or good morning or good evening, Jay. Jay.